So we are going to do a lot of graphing. Today, I'm going to introduce you to what the sine curve looks like. All right, you've been doing sine of 30, sine of 60, 45, but it's an actual graph. Sine is an actual graph, and so is cosine. And that's what I'm going to expose you guys to today. First, we're going to go step by step here, finding the values of sine at all these degree measures and filling in the chart for me. And then I'll help you graph it, and we'll take a look at what the sine graph looks like. So first thing in your calculator, we're going to hit the sine button, and we're going to go to the first value on our table. Sine is 0. And you're welcome. I'm getting a little soft today. I'm allowing you to use your calculator instead of going to the unit circle, right? Sine of 0 is just 0. All right, what about sine of 30 now? Sine of 30. What are you getting? 0.86 or about 0.87? Oh, half. Sorry, I'm thinking about the wrong thing. So 1/2. And look, this is stuff we know, right? Because sine's the y value, and the y value at 30 is 1/2. 60, that's your point, about 0.87 we'll put. All right? And that's your radical 3 over 2 from last unit. 0.87, radical 3 over 2. All right, let's keep filling in the table here. What about sine at 90? 1, yep. Let's keep moving here. Sine of 120, I think, goes back to 0.87, right? Sine of 150, if I keep trucking here. 1/2 again. And then at 180, 0. 210. Okay. Oh, now, and that makes sense why my values are negative. Because what quadrant am I starting to enter now at 210? Third. And what do we know about sine at the third? So this is all connecting now. Yeah, my value should be negative now for the rest of the time. What is it? Negative 1/2 at 210? 240, negative 0.87. What about at 270? Sine of 270? Negative 1. 300. Back to negative 0.87. 330 should be at negative 1/2. And then at 2 pi, we should be at 0. Okay? All right, so let's go to the graph. And what does this look like on the graph? First thing I need to tell you guys, anytime we graph a sine or cosine graph, look at my x-axis. You guys are used to this as your x-axis, right? 1, 2, 3, -1, -2. That's your x-axis. But when we graph sine and cosine, your x-axis is always in radians. Okay, so just get used to that. All right, don't freak out. It's fine. It's not going to affect you guys at all. But pay attention. This right here is not 1. This isn't 1. Okay, that is actually going to be, take a look, pi over 6. Okay, so each tick mark, pi over 6, pi over 3, pi over 2. We graph in radians. All right, you don't need to label it for me. So just leave it as the tick mark there. All right, where are we going to start? At 0, what's the y value? 0. So here's your first point on the sine curve, 0, 0. So now let's go in radians. The next one's going to be pi over 6, and you're going to graph positive 1/2 right here. Okay? Next tick mark is pi over 3, and that's 0.87. Do your best. Do your best. All right? I'm not looking for greatness and exactness. Do your best. Right below 1, right? Next tick mark is going to be pi over 2, and now you're going to graph 1. And now we start repeating again, right? Now it goes back to 0.87 at 2 pi over 3. 1/2 at 5 pi over 6. And then at pi, we're at 0. And now we should be going on the y-axis down in the negative direction. So keep going. Finish this off for me. I'm going to do a little cheat code here, but finish it off with all your points. And you guys can do this cheat code when we're done with class today. You'll understand it. Good work, good work. All right, this is a sine curve. Curve meaning it's smooth. It shouldn't look like you're at the hospital with the heart monitor. All right, or it shouldn't look like peaks and valleys. All right, should be a, ready? Smooth, and I'm the worst at this. Worst. Smooth curve. Okay. What you see in front of you right now is the sine curve. That is one full sine curve right now. That is what it looks like. Now, what if I said, hey, you know what, guys? Let's go nuts. Let's graph past 2 pi out to the right. You know what you would see? Repetition. All right? It would start repeating itself again. Okay? This right here is one full sine curve. Well, what if we did in the negative direction? It's going to start repeating again. Okay, everyone see. Good. We will very rarely travel over in the negative direction, but I want you to understand from 0 to 2 pi, this graph from 0 to 2 pi is the sine curve. Anything else to the left, it repeats. Anything else to the right, it's just going to repeat itself. Oh, good. We're good? All right. This will be the last time for a sine curve I ask you to fill out a darn table. Last time. I need you to know what happens from start to finish. So we're going to take a couple notes down here of what happens to the sine curve. This is the most important part. First thing I need, where does sine start? Where does sine start? Starts at 0. That's the first thing we got to remember about the sine curve. Starts at 0. Ready? Then goes where? All the way up to? All the way up to? Okay, but I'm not going to say 1. I'm going to say it goes up to its maximum. All right, everyone, maximum, the highest point, because sometimes it's not going to be 1. So goes to max. Okay, after 0, it goes to its max. All right, keep traveling along the curve, then it goes back down to where? Well, even before that.
0.
Goes to 0, back to 0. Back to 0. Then goes where? 0, then it goes down to -1, but I want to call that the what instead? Minimum, because it's not going to be -1 every time. So goes to minimum. And then ends where? Ends at 0. This is for every sine curve we do. I do not want charts filled out. I will never require it. Here's what I'm going to require. You know it starts at 0, goes to the max, back to 0, to the min, ends at 0. Every sine curve we do. Every sine curve will look like that. Any questions on the sine curve before I throw a little wrench into it? See you later. Got to make sure this is made up. All right, number 2. Go ahead, flip it over. Very small change. What is it? I took the y equals sine x and put what with it? What's the small change? What did I put? What's the small change from this versus the last curve we just did? It's got a what?
4.
Doesn't have a 4, right? Y equals sine x, so we put a 4 there. That 4 is pretty powerful. Let's first give a vocabulary term to that 4. That 4 right there, that number out in front, is referred to as its amplitude. Amplitude. That now tells you how high and how low it's going to go. So it's not going to go to 1 and -1 anymore. It's going to go up to 4 and down to -4. That's what that number out in front, the amplitude, tells us. All right? So graphing it, no table. Don't want it anymore. Takes too much time. Where does sine start? Okay, so guess what? It's going to start at 0, guys. Sine always starts at 0 for now. Next week, that may change. All right, keep telling me something about the sine curve. Starts at 0, then goes to where? It's maximum. Not 1 here, but 4. And that's every time I have this pi over 2, pi, 3 pi over 2. It's going to have one of these key, what I'm going to call key values. So now it goes up to 4. That's its new max. 0, max, then it goes back to where? What did we just write down? 0, max, then it goes back to where? 0, but that's going to be at pi now. Then goes down to minimum, which is now what? Negative 4. Not negative 1, but negative 4 at 3 pi over 2. And then where do my sine curves end?
0.
At 0. There it is. Okay? We just got to know the direction. And that's what my expectations are. There's not going to ever be a table to fill out. We just got to know, where's it start, where's it go, where's it end. All right, we do have to answer some questions about it though. All right, second vocabulary term, which is period. I'm not going to get too hardcore into it until next week. The period of a graph is how long on the x-axis does it take before it repeats itself again. Okay, how long on the x-axis does it take before it starts repeating again? And we know, I just showed you guys, what happens after 2 pi. It would start repeating again. So all our answers for period for now, from now until at least sometime next week, is it takes 2 pi on the x-axis before it starts repeating. That's what period is. How long on the x-axis, how many units does it take before it starts repeating? And right now, anyway, that'll change next week, but for right now, it's 2 pi. All right, let's go back to Algebra 2A last year. Range was your what values? Range were your y values. So you tell me, y values, from what to what does this graph go? Y values, from what to what? 4 to negative 4, right? But I'm going to have you guys write in a notation you should be familiar with from last year. Remember doing brackets or parentheses, interval notation, I think it's called. Does it include negative 4? Is negative 4 part of the graph? So that gets a bracket. Negative 4, comma. How high does it go? And does it include positive 4? So that is also going to get a bracket. Nick?
Could you also write it in the such that one where it's y such that?
Okay, if you're going to do that, then you got to make sure you do the multiple inequality thing here. Yes, you could, but you got to make sure you got both inequalities. Okay. Also, another common mistake I see is make sure the smaller number always goes first when you write the interval. Okay, smaller number first. We okay on range? All right, next. What interval is it increasing? Increasing. If I gave you the pen right now and said, come up to the board, circle where it's increasing. What do I have next?
We don't have that.
Yeah, you do. Part D. It's not part F on yours. It's part D on yours. Okay, it's the next one. Okay, yeah, I crossed those out because those used to be on the notes, but they're not anymore. So, okay, so where is it increasing? If I gave you the pen and say, get up here and circle what parts of the graph you think are increasing, I'm hoping you would circle this part, right? That's where it's increasing. And any other places you would come up and circle? Jake?
3 pi over 2 to 2 pi.
That part right there. So how do I write in interval notation that it's increasing there and there? You use its x values. It's x, not its y's, it's x values. So the first part it's increasing is from 0 all the way to where on the x-axis? Pi over 2. From 0 to pi over 2. And when we write it, we're going to write it with parentheses, and I'll show you why. So from 0 to pi over 2. Now, why do I write it with parentheses and not brackets? Because at 0, it's not doing anything. It's just a point. It's not actually increasing at 0. And the same thing at pi over 2. It's just a point. It's there. It's not increasing. And now that you know that, and I know Jake just gave this away if you were listening, but it's fine. How would you express the second part of the graph where it's increasing? From what to what on the x-axis?
3 pi over
3 pi over 2 to
2 pi.
2 pi. Okay, so that always gets parentheses, increasing, and I may ask decreasing. And last question before we move on from sine. What is the line that splits the max and min in half? So everyone take a look. Here's your max. Here's your minimum. Can you guys find a line that splits those two, halfway in between those two? Halfway in between those two. What's the line that's halfway in between the max and the min? It's the line that cuts it in half is your, everyone agree, x-axis. Yep. X-axis. All right, before we leave, not class, but the sine curve. Where does sine start?
0.
0 goes to the, after 0 goes to the max, then back to where?
0.
0, then to the
Minimum.
minimum, ends at
0.
0. That's what we got to know. That's it for sine curve. Everyone all right with that? Because cosine follows a different route. Cosine goes somewhere different. Okay, so let's talk about cosine then. Let's do the same thing we did with sine. Grab your calculators. Anybody right off the bat, cosine is 0?
1.
You sure about that? Cosine of 0 should be? Oh, whoa. So cosine starts where? Not the same place as sine, right? So that's already different. Already a difference between sine. Does not start at 0. The other values will look familiar. What at 30? 0.87? 1/2? 0? And then we keep going down, right? What is it? Negative 1/2 next? And again, makes sense because look, 120 degrees, you're entering quadrant 2. Cosine's negative in the second quadrant. At 180, negative 1. Now we start heading back up. You guys go ahead, and you guys have done this with sine, so you should be good at, should be all right here. And then here comes fourth quadrant, and shocker, they're positive there. All right, let's graph it. So where does it start? Doesn't start here anymore, right? That's the sine curve. Starts at, we're starting at 1. And then you guys go ahead and let's graph a few points. And same thing as the sine, smooth curve. This is not a V formation. This is a smooth curve. Definitely different than the sine curve. And again, this is cosine. I ask you guys to keep graphing. I'm going to see it again. I ask you to on the negative side. That's awful. What am I doing? I'm going to see it again. Okay, that right here, what you see is one full sine curve, or cosine curve. All right, here you go. Notes. I don't care about a chart. I care about, where it starts and where it goes and where it ends. All right, where does it start? Okay, yes, at 1, but it may not be 1 all the time. What do we know about, what can we call that 1? That's its max. So cosine starts at the max. Starts at, don't think 1 because that may change, right? If there's a number out in front. All right, starts at max, goes to where? Goes to, we'll stop there at 0. Then goes to where? It's minimum. Then where? Minimum, then travels back to 0. And then every cosine curve, well, I shouldn't say every, ends where? Ends at max. All right. And we're not doing tangent. This is it, sine and cosine. Questions from you guys? All right, I want to go in reverse on this next problem. I don't want to graph it. I want to see if you guys can just look at the equation and answer some questions for me. All right, answer some questions. So 1/2 cosine x, what's my amplitude? It's the number out in front, 1/2. And again, that 1/2 is powerful because it tells you max and min, 1/2, negative 1/2. Period, it's always going to take out to 2 pi to make a full curve before it starts repeating. That's just going to be common until next week. All right, speaking of that, max value, how high is this curve going to go? All the way up to, I say all the way, but positive 1/2. Yep, that's what that amplitude tells you. It tells you what your max is. And that must mean the min it'll go down to negative 1/2. Good? And then knowing that, how can we write our range now? Range, y values. From what to what?
-1/2 and +1/2.
Negative 1/2. Make sure the smaller one goes first to positive 1/2. Yep. All right, ready to graph it now? Because I think that's the next part, right? Graph it. Yep. All right, let's go through the note. Let's go through the notes. Where does cosine start? Cosine starts at its max. Starts at its max, which we already established was 1/2. So it starts at 1/2, goes to where now? Next key value? Starts at the max, goes to 0. So pi over 2 is 0. Then travels to where? It's min, which in this case is negative 1/2. See how this works? Back to where? 0. And then the cosine curve always ends at maximum 1/2. So there's cosine 1/2 right there. That's awful. All right, where is it increasing? Or decreasing?
Pi over 2.
Can we decreasing? Decreasing. Can you think you can circle it before you tell me? This whole thing, right? going down the whole time, right? Just not two little pieces like the last answer. So parentheses, always parentheses with increasing and decreasing. And this is on the x-axis. Where is it decreasing? So it starts decreasing at 0 and stops decreasing at pi. 0 to pi. Anything I can answer. I got one little new addition, and then you guys are going to start graphing on your own. Any questions? Last thing I want to show you. What's different about this graph now?
Negative.
Okay, the negative sign. Everyone agrees the negative sign. It will still go up to 2 and down to 2. That's not going to change. Here's what the negative does. If you see a negative sign, any max becomes a min. Any min becomes a max. Basically, what I'm saying here to you guys is the graph flips over the x-axis. Zeros stay 0. They don't change. But if you're going to tell me it goes to its max, you better stop and flip it over to its min. So it flips. All right? So where's sine usually start? Where's sine start? And it's going to stay starting at 0. The negative does not affect that. Something else will affect it next week, but for now, we're starting at 0. Sine curve. Look back if you need to. Sine starts at 0, then goes where? To its... Where does sine go after 0? Starts at 0, goes to max, but it's a negative out in front. So now I'm actually going to go down to the minimum, which is what number? -2. Everyone see what the negative does now? Yes, usually I would graph +2, but the negative says, no, no, no. I flip it over the x-axis. Okay, now where? Back to 0. That doesn't affect it. And at this point in the graph, yes, I would graph the minimum, but I got to flip it and graph the max. So that's all the negative sign does. All the negative sign does, and then where's sine end? That doesn't affect it. All right, so only the negative affects maxes and mins. All right, questions? Okay, we still have 11 minutes, so plenty of time here. Chromebook's out. I want you to look at the answer key while I walk around and watch you graph. All right, that's all you're doing for me here is graphing all the different types of versions of everything.